multiplier. We will reverse it and we will see in real life also you have seen this one, reverse operation of on signals. And this is reverse operation. If we put minus here, if we put negative values for independent variable, then that operation is nothing but time reversal operation. Let us consider x of t as this one. If we reverse it, that means instead of taking 1, we will take minus 1. And now it will appear for minus 1. Are you getting my point, ma? Reverse. We are doing reverse operation. And this last 3 graphs, last graphs showing which we have considered previous example. We have considered this is original signal, no previous example. Previous example. This is example signal. For this signal, now I am going to explain time reverse operation. Time reverse means x of t is equal to, here you have to put x of n. X of n is equal to x of minus n. Now what is the operation we are taking? Reverse operation. So put n is equal to minus n. So you will get, calculate the value for minus 2 value. We have to plot this one. For minus 2, what is the amplitude? You have to calculate. This is the original signal. Students, are you, my cursor is visible, ma? Anyone reply,
Yes,
please? The above signal is original signal. The below signal, x of minus n. X of minus n is reversed signal. And how we will get means the same for minus 2. What is the value? Calculate here. Put minus 2 here. What it will become? My x of minus 2.
plus 2x of 2.
Plus 2. So x of 2. What is the x of 2 from the original signal? What is the x of 2 here? It is 1. So we will put this sample to here. And next, for n is equal to minus 1, you take minus 1 and substitute here x of minus 1. What it is? Minus of minus 1 means?
X
Plus
of
1.
1.
X of 1. From the original signal, what is the x of 1?
2.
2. So now for n is equal to minus 1, we have calculated and the value is 2. And x of 0, x of minus of 0 is 0 only. So x of 0, what is the value here from the original signal?
3.
3. So it will be same. There is no change. If we reverse also, 0 is 0 only. There is no minus negative values. And next, for n is equal to 1, you substitute n is equal to 1 here. X of minus 1. So what is x of minus 1 from the original signal?
Minus
this is
1.
x of minus 1. It is minus 1. Amplitude is now minus 1. And next, for n is equal to 2, you substitute here x of minus 2. X of minus 2 is our new signal. X of minus 2 is what value here? 2.
2.
From the original signal, the value is 2. And it will goes to our reversed sequence. So if you see, it is reversed. It have got reversed. Minus 2 is become plus 2 here. Minus 1 become 1. 0 is same. 1 is minus 1. 2 becomes here minus 2. It is reversed. Very easy one only, my you are following. It will be very easy only. Are you following?
Yes, ma'am.
What about remaining people? Are you following?
Yes, ma'am.
Yes.
We just reversed. We just reversed. X of n is equal to x of minus n by taking negative independent variable, negative value. We just reversed the sequence signal. Now the third property, the third basic operation, which is very, very important, that is time scaling. Time scaling, name itself indicates we are going to scale. We are going to increase or decrease independent variable. We are not scaling amplitude. Next slide, I will explain scaling of amplitude. Now we are doing basic transformations on independent variables. What we are doing now? We are doing transformations on independent variables. First one we have seen time shift in time. We shift it to by T naught or minus T naught we have shifted. And second one we have reversed. And third one scaling. Here we are multiplying independent variable T with a constant A. And here also for dt signal, we are multiplying independent variable with a constant A. This A may be greater than 1 and this A may be less than 1. If it is greater than 1 means 2, 3, 4, 5, 6, those values comes under here. And also minus 1, minus 2, minus 3, minus also comes for det of A greater than 1, where the signal is called linearly compressed, and linearly stretched signal for det of A less than 1. And it will be just reversed in time for negative values. If we substitute here negative values, if we substitute minus here, excuse me, if we substitute negative values here, minus, then we will get, I have explained in previous slide that if we put here minus, we will get reversed signal, reversed. And this is about stretched and compressed. If that A value is less than 1, the signal is linearly stretched. That means expanded. You see here, the first 3 graph showing for continuous time domain, and next 3 graphs showing discrete time domain. See here, for continuous time domain, if we scale, that means if we multiply a constant 2 with our independent variable T, then what will happen? The resultant signal. If we multiply a constant 2 which is greater than 1, it will be linearly compressed. It will be linearly compressed. Is it visible, ma? Compressed version? Compressed version. The same signal, independent variable is multiplied by a constant 2. So we have a compressed version of, there is no change in amplitude. You see here, the amplitude is same only. There is no change in amplitude. There is change in x-axis only. It may be compressed, it may be expanded. So where we will use this operation means, for example, in image processing, to enlarge the images, to compress the images, we will use this one. Where we will use compress of image, if the image size is large, particular applications want small size images, there without compromising the quality, with same quality we are going to compress. We will going to compress that image. There we will use this time scaling operations. And coming to our dt signal, this is our original signal, and this is now compressed signal, which is compressed by a factor 2, x of 2n. Now we have to plot x of 2n. For that, what we have to do? start from putting n is equal to minus 1. N is equal to minus 1. If you substitute here, what is the value, ma? N is equal to minus 1.
Minus 2.
Minus 2. Minus 1 in the place of n. So you will get x of minus 2. What is x of minus 2? From the original signal,
2.
it is 2. Amplitude is 2. So it will come here. And next n is equal to minus 1 is over. After minus 1, what is the value? 0. Substitute 0 here in the place of n.
X of
In the place
0.
of n, substitute 0. X of 0. What is the x of 0 from the original signal?
3.
It is 3. So n is equal to 0. The same n is equal to 0 value comes here. Next n is equal to 0. Next, what is the value? N value? 1.
1.
Substitute n is equal to 1 here.
X of 2.
2 into 1. X of 2. From the original signal, what is the x of 2 value? It
1.
is 1. Amplitude 1. So x of 2 amplitude will come at n is equal to 1 now. So by seeing itself, we can say what is the operation we have performed here? We have compressed, isn't it, ma? By seeing these first two graphs, we can say compressed version. Next, if the factor, this a value less than 1 means let us consider 1 by 3. A is equal to now 1 by 3. 1 by 3 into n. Now here in last graph, what is the a value, ma? We are taking a is equal to
1 by 3.
1 by 3. Now a is equal to 1 by 3. We are going to plot x of n by 3 now. For that, first substitute, you start from minus 6. By doing some examples, you will yourself get why we are starting from minus 6. Why we are starting here from minus 6, ma? Because we are having sample at minus 2. In original sequence, from where it is starting? Minus 2. You equate this minus 2 is equal to n by 3. You will get n is equal to minus 6. So from where we have to start now? From minus 6. Put minus 6 here. X of minus 6
Minus
by
3.
3. X of 2. X of 2 value now. X of 2 value is what, ma? X of minus 2.
X of minus 2. 2, ma'am.
2. X of minus 2 is equal to 2 from our original signal. And this will comes here minus 6. At minus 6, what is the value of x of